Now we've been looking at the derivative, and in particular we've defined the derivative to be the limit of the difference quotient. Now we want to look at what does the graph of this derivative function look like after we find the derivative. Before we actually find the derivative evaluated at any particular point, we have a function. How does the graph of that function compare to the graph of the function where it came from? In other words, the function that we differentiated to get the derivative. Well, let's take a look at that. Here's the graph of f of x equals x squared. And let's take a look at something here. Let's look at a tangent line that coincides to x equals -3. Now you notice that this tangent line is decreasing, so it has a negative slope. So if you wanted to find, if I wanted to take this slope and plot it, plot the value of it, so the x-coordinate would be -3, and then I wanted to find the corresponding y-coordinate, I would have -6. Now recall that I'm using this example because we know that the derivative of x squared is 2x. So if you plug in -3 into 2x, you get -6. But notice that that does correspond to this negative slope. Now let's go to the next level and look at, well, what about if we've got -2? Now one of the things you'll want to observe about the slope of the tangent line at x equals -2 is it's not quite as steep. It's still negative. And notice in particular how that corresponds to the fact that the curve is decreasing. So notice this curve is decreasing, and sure enough, when you put a tangent line at a point on that curve, when the curve is decreasing, the tangent line will invariably be negative. Now notice here at -2 we have this slope, and if we were to plot that point, we get -4. In other words, I'm plotting the point -2, comma, and the slope of this line, which is -4. Okay, now let's go to -1. And once again, we see the slope, or the tangent line, and we notice that the slope this time is not quite as steep. So notice, when the curve, as the curve was steeper, we had a steeper tangent line. As we go from the left to the right, our tangent lines have a smaller and smaller absolute slope. Now let's plot this slope, and notice we get -2. Now let's go to the next one at 0. Now notice that this, right at the bottom of the graph, the tangent line would have a slope of 0. And if we were to plot that, sure enough, we get a point right at the origin. Now if we continue this on and look at x equals 1, now notice something's happened here. Notice that the graph is increasing, and that corresponds to the tangent line having a positive slope. And now if we were to plot that, we would find the point 1, 2. Now let's go to the next one at 2. And we see an even steeper slope, positive. And if we plot that point, we find that we get a value there at 4. So remember, what we're doing is we're plotting all the x values, and they're corresponding the slopes of the tangent line. So really, we're seeing if we can figure out what the graph of the derivative looks like. Now remember, we already found that the derivative of x squared is 2x, which is linear, having a slope of 2. Now let's look at another one. Let's look up here at 3. Okay, the tangent line at 3, notice, is yet steeper than the others. And if I were to plot that point, notice it would be 6. In other words, remember what these big blue circles are. These big blue circles are they form the y-coordinate of the ordered pair, where, for example, in this case, this last one, we had the x-coordinate was 3, and the corresponding slope was 6. Now let's see if we can see what the line might look like. If we run a line through all these points, we notice, well, there's the graph of the derivative. This is the function f prime of x equals 2x. And notice this. Here's what we want to notice. Notice that as the graph decreases, we had negative slopes, and that corresponds to the derivative function being below the axis. Now here at 0, we had a 0 slope. Then the function begins to increase, and notice that that corresponded to a derivative being above the x-axis. In other words, we had positive slopes. Now let's look at another example here. What I've got here is I've got the blue graph is the graph of a function, f of x. And I went ahead and I've graphed the derivative here that in a similar fashion to the previous example. I've just went ahead and graphed the derivative. Now, I want to take note of something. Notice this, that as long as the graph, the function is decreasing, and it does all the way down to this blue disk, the derivative is below the axis. Now notice everything changes at the bottom of the derivative at a minimum point here. That corresponds to where the derivative is crossing the axis. So notice, just as the function goes from decreasing and then transitions over to increasing, the derivative goes from being below the axis to above the axis. And notice the next point of interest is over here, where notice that the function is increasing all the way from the first blue disk to the second, and that corresponds to the derivative being above the axis. Now notice how that it's right back on the x-axis at 0. That corresponds to this maximum. In other words, where the function is about to begin decreasing again, the derivative is poised to be below the axis. Now this continues, notice, until over here. Notice the blue disk, we continue to decrease, decrease, decrease. And as long as we're decreasing, notice that corresponds to the derivative being below the axis. Here we end up, now we're ready to, the function is beginning to increase, and notice that corresponds to the fact that the derivative function is poised to be above the axis. Now, here's what we need to remember about this. When f prime is bigger than 0, that corresponds to the function increasing. So, if we see the derivative is above the axis, we know that f of x is increasing. Likewise, if we see f of x increasing, we know that the derivative is positive. Now, if, on the other hand, we see the derivative below the axis, if we're looking at a graph of a derivative and it's below the axis, we know that f of x is decreasing, and vice versa. If f of x is decreasing, we know that the derivative, the graph of the derivative, will be below the axis.